Alright. Sorry, well, hopefully you had a good spring break. Your grades are on Canvas. I have an input, since this is only, I think, like week 8 or 9. So for your homework, you have 50% of your homework done because we've only been half of the semester. So don't look at the total, because if you look at a total, you think you might have a bad grade, but that's because we haven't taken more tests and we haven't done more homeworks, or we haven't done any quizzes. So since this is still continuing, I'm just gonna put the quiz at the beginning of the video. So here's a quick quiz, just a quick reminder. See if you can solve this inequality here. So see if you can solve this, and make sure you write your solution. You want to make sure you graph your solution, graph it, and then write your solution in interval notation. So after you solve this, graph it and write an interval notation. The reason why I'm doing this is because even though we're going to take a quick break from looking at inequalities, we're going to get back to it. So just a quick reminder, see if you can solve this. For the quizzes, just post them on Canvas, if you can do that. So send them to me through Canvas, and then I'll look at your quizzes that way. Alright, so let's continue. So like I said, we're going to take a break from inequalities, but we're going to jump to 2.4. But before we get into 2.4, and 2.4 is looking at linear equations in two variables. But before we jump into that, again, we're going to be graphing linear equations. We're going to find the slope and all these different ideas. A linear equation can be written a couple of different ways. So one of the main ways you probably remember it, I'm sure that's the first thing that came to your mind. Well, hopefully. If not, it's okay. Y equals mx plus b. This is called slope intercept. That means the int means intercept form. And there is ax plus by c. This is just the standard form. That's just the standard form, a linear equation. And again, it's a linear equation in two variables. The two variables that we're looking at, of course, is x and y in both of these situations. So that's what we're going to be focusing on for a couple sections. Again, I've been jumping around just because in 2.1, 2.2, and a couple other of the sections deal with functions. And before we get into functions, I just want to recall, if you guys remember, how a graph and all these things. So I'm going to do a quick review about graphs in general, at least the x and y plane. So I'm going to do that right here. Let me move this a little down, a little up. So hopefully you guys remember this graph. It's a fancy name is the Cartesian plane, or You can also call it the XY plane. I don't know if you guys remember that. The reason why they call it the XY plane is because this horizontal line is your X axis. And the vertical line is your Y axis. And then split up into 4 different sort of pieces. 1, 2, 3, 4. And those 4 pieces, they actually have a particular name. And that name is quadrants. So this is known as our first quadrant. I'm going to put it over here. Hopefully. First, I'm going to just use capital Q for quadrant. This is our second quadrant. I'm just using Roman numerals. So that means 1. That means 2. This just means 3, our third quadrant. And this means 4, which is our fourth quadrant. So hopefully you guys remember this. First, second, third, fourth quadrant. And hopefully you remember what goes on this graph are points. So we sometimes call them points, call them coordinates, or call them an ordered pair. I don't know if you guys remember all these 3 names, and that's just for this. That's considered a point. This is just a singular. Points, of course, would be more. Coordinates. So this is the X coordinate, that's a Y coordinate, and ordered pair. The way I like to think about that is because if you think about the alphabet, X comes before Y in the alphabet. So hence, it's an alphabetical order, and it's a pair because they always come in 2. So there's always an X and a Y. So always come in pairs. But there's specific. So this is just in general what you call this: a point, a coordinate, an ordered pair. There's a couple other specific points, coordinates, ordered pairs, and I'll denote that right now because there is a point right where both the X and the Y axis meet. This is the coordinate 0, 0. So that means you have not done anything to left or right, or you have not moved this coordinate ordered pair or point up or down. And this has a very particular name, and it's known as the origin. It's like the point where these 2 axes intersect each other. Now, let's look at what goes on. A couple other things. I sort of just jumped ahead, but hope you remember that on this side, all these here represent positive X. So hopefully you can see that. So all these are positive X values. Here represent all the positive Y values. On this side, this represents all the negative X values. Here are all the negative Y values. And once we actually look at how to put this ordered pair or point or coordinate on the graph, knowing that this is these are the positive Y, positive X, negative Y, and negative X, becomes important. So yeah, I'm just trying to get terminology out here. So first, second, third, fourth quadrant, Y-axis, X-axis. This is a point, coordinate, an ordered pair, and then we have a specific ordered pair, which is the origin. And that's where the x and y axis intersect each other. And now, there's a couple more ordered pairs that are very specific. I might have to just make another graph because I don't want it to all be bunched up in there. So it's still the same thing. Hopefully this is not too unorganized. I should have put this on a different sheet of paper. I know that for the next video. So what I'm talking about is, again, everything's still the same. That's the origin. This is the x-axis, y-axis, first, second, third, fourth quadrant. All those things still apply. But there's a couple more points on these graphs that have very specific names. So for instance, if the point happens to be exactly on the x-axis, it's also called an x-intercept. Hopefully I spelled that correctly. Or for short, XINT, so x-intercept. And what all the x-intercepts have in common is that, remember how I said this is the positive axis, this would be the negative axis. All of these have some number for the x-coordinate. It might be on the positive side, it may be on the negative side. But something that they all have in common is that their y-coordinate is always 0. And the reason why it's always 0 is because to have a negative or positive y, remember, it has to be up here. So these points would have to either move up or move down to have something else other than 0. But all these have the same thing in common because they're on the x-axis. That's why they're called x-intercepts. So that's going to become important when we look at over here, when we talk about the slope-intercept form. So this intercept is a very specific intercept. It's actually the y. It's a y-intercept. And hopefully you ask yourself, well, if there's an x-intercept, is there a y-intercept? And there is. Let me show you. So the y-intercepts, hopefully you guessed it, are points that are on the y-axis. So these are known as y-intercepts. And again, for short, y-int. And just like the x-intercepts, there's something that all these y-intercepts have in common. Hopefully you guessed it, they're all on the y-axis. The only thing that changes is the value of y. Because look, these are on the positive side of y. This is on the negative side. So there'll always be some y value for your y coordinate. But if you notice, these don't shift left or right at all. They're perfectly on the y-axis. So that means that they have to have a 0 on the x. And I'm going to bring back this idea throughout this entire course. So it's good to remember some of these terminologies that maybe we haven't seen in a while. But here we have, again, this is the x and y plane, or some people call it the Cartesian plane. This is the first, second, third, fourth quadrant. Positive x's, positive y's, negative x's, negative y's. Where they meet, it's 0, 0. So that's the origin. And all these points are called coordinates, ordered pairs, points. This has a little more specific name, which is the origin. So these points as well have a more specific name, and they're known as x and y intercepts. I'm going to do a quick example on how, so you can see how these stay exactly there. hopefully I can fit it here. See if I can block this off. Hopefully this isn't too bad. So I'm going to do an example. I'm going to plot the following points. If you don't remember, if plotting is taking an ordered pair or a point or a coordinate and actually putting it on your XY plane. So let me make an XY plane here. Hopefully it's not too confusing. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Hopefully you understand that this represents positive 1, positive 2, positive 3, positive 1, positive 2, positive 3. This would be negative 1, negative 2, negative 3 for your X. Then we have negative 1, negative 2, negative 3 for your Y. So let's plot some points. Just going to do it at random. I'm going to do 2, comma, negative 2. Again, since this is, and let's do a couple more. Let's call this A. And then we'll do another one. We'll do 0, comma. Let's do negative 3. Or, yeah, we'll do negative 3. And we'll call this B. And we'll do another one. Let's do negative 3 and 2. And we'll call this C. Alright, so the way I like to graph them, again, hopefully you guys remember this. This is just a quick reminder of the XY plane. And then I always like starting at the origin. And since this is considered an ordered pair, I like to go in order. I start with my X and then I proceed with my Y. So for A, if I start at the origin, I have a positive 2 for my X. And remember, the positive X's are on the right hand side. So that means I'm going to move over to, that doesn't mean this is where my point's going to be. I need to now satisfy my Y coordinate. And the Y coordinate is negative 2. And the negative Y's are below the X axis. So that means I'm going to go directly to below, and that's where my A is. Similarly with B, again, I always start at the origin. Since my X is 0, that means I'm not going left or right at all. I'm staying right here at the origin still. But then for my negative 3, I actually have to go down 3. Because that's where negative 3 is. And the negatives, Y's are below the X-axis. Here's my B. You can see that. And lastly, for C, again, I start at the origin. But since my X is negative 3, I move to the negative 3 side on the X. And then my Y is positive 2, so that means I'm going to go up 1, 2. And there's my C. Hopefully that's a good enough reminder of the XY plane and how it works. Because now we're going to have to try to get into graphing. I'm looking at these linear equations. So I'm going to stop the video here. I'm going to make another video because this took already 20 minutes. I'd rather make another video. So it's just dedicated to looking at linear equations. no homework on this one. I'll probably post homework on the next video. So don't forget the quiz. Post it on Canvas if you can. Send it to me through Canvas. Take a picture. Make it a PDF. Send it to me. I can check it really quick. Thank you.